in terms of the seed germination lab, again, deadline it's due on April the 12th. Okay, April the 12th in the beginning of the period. Now, in terms of what you will need to hand in that time, you will need to hand in a hard copy as well as upload the electronic version onto Brightspace. Okay, upload the electronic version on Brightspace. It will be running through Turnitin. Okay, it will run through Turnitin. So this is especially the important part for especially important for the individual portion. Okay. I'll create different Dropbox for them. What do you need to hand in? So let me just, again, part of it, I mentioned it last Friday. So you will need to hand in your design phase. This is your group part, okay? Updated RQ, research question. Updated independent variable, dependent variable, controlled variable, as well as updated flowchart of the method, okay? So during the experiment, you guys have tweaked or changed your original flowchart. Different numbers were put in. Some of you guys add some water to each bag during those 3 days. Okay, you do need to record those. Okay, part of the whole thing about doing experiment is so that other people can read your procedure and read your experiment and be able to replicate the same thing and should get similar results. Okay, so let's just say someone from Ms. Lam class saw your flow chart. They can look at the flow chart, do exactly the same thing. Okay, so that's the purpose of the updated flow chart law. Any questions on that? Okay. Data and observation. Observations. So a couple of things. I will need you guys to have raw data tables. Okay, your raw data table. I'm going to separate them into different things. So your raw data table, you will need to have each day, again, each day, just like what I drew on the board over there, each day, the values. Now, the values that you have, as well as any written qualitative observation. Now, this part here, I will expect you to actually tweak your data table. When I say tweak your data table, I'm not saying you tweak the result or the value. I expect you to have the data table consistent to the format up here. Okay, so this is an example of a data table and what you should have. So you should have a title on the top that is very clear. You have your independent variable. Usually it's your independent variable on the side, and then your dependent variable. What you will notice is this: the unit is under the heading. You only show it there once. Afterwards, you don't have the units down here. Okay, a lot of people lost mark on that last year. This here, the plus or minus 0.1. These things are what you call uncertainties, okay? Uncertainties, especially for the instruments, especially for your instruments. So in this case, your uncertainty would typically be the smallest value of your, in terms of number of decimal place. Now for you guys, because you guys did things, because you are just your raw data, it's like, oh, how many seed germinated? There's no plus or minus, okay? So lucky for you, your raw data table, I should not see any plus or minus. However, later on, I do expect to see some kind of indication of significant figures. Okay. Questions so far? Okay. So make sure your table. Yes.
That part of the table is percentage. We wouldn't need the plus or minus.
Well, the thing is this, your raw data table should not show the percentage yet. The idea, typically, when you're doing raw data table, basically, it's you didn't do any math. There's no addition, there's no subtraction, there's no calculating the percentage. That is the raw data table. Now, when you guys, what you might have written on paper or collected on your table, you might need to kind of rework back, okay, and see and you hopefully should have had written down oh yeah, 25 seeds, 10 of 25 seeds were germinated. Okay, are you guys good? So raw data table, just to be clear, is before any math taking place. Okay.
So the tables you've been doing so far.
Sorry, say again.
So all the tables you've been doing so
far. Yeah. Well, yes, but I want you to update the formatting. Okay. No, like that.
Oh.
Title, have a title. The headings need to be clear, showing the units. Okay. Because that's rough. You hand this in like that, you'll lose a lot of mark. Okay. Okay. So that is your raw data with qualitative and quantitative observation. Now, your process data table. What do you need to do for your process data table? Now, a couple of things. I'm going to go back up here. So, in this case here, this part, I'm gonna need to make some changes for this one here. Oh, wait. So for this one, use your raw data to calculate your dependent variable, okay, for each entry of your table. Okay, so when I'm saying dependent variable, we're talking about percentage germination. We're talking about the rate of germination. Okay, so you have to calculate that per any of those boxes. After that, you should calculate the averages of your trial. So in this case, if we look back here, let's just say this is your day one value. Okay, this is your day one value of number of seeds. Let's just say you're doing percentage germination. Okay, then in this case, you'll find the averages of all 4 trials of the control, averages of the variable 1 or 2. Okay. And afterwards, you will do something called, you calculate the standard deviation. Now, put up your hand if any of you have heard of something called standard deviation before today. What does that mean? So what do you mean by uncertainty?
So it's like a range of values. It could be like plus minus.
Kind of. Yes. So let me just quickly explain what that is. Come on now. Okay. So when we're talking about standard deviation, the idea is this. Let's just say there's two sets of values. Set one, you have 5, 5, 6, 4, and 5. Okay? What do you think the average of this would be? Probably 5. 10, 20, 25. So the averages of this will be 5, right? But if I do a set of, let's just say 5, 10, 0, 8, and let's just say 2. Is it 2? Yeah, 2. So in this case, if I do the average of this data set, the average would also be 5, right? Does it make sense? 10, 20, 25 divided by 5, 5. Okay? Oh, it's really easy. Sorry about that. Okay? So these two set of numbers, they both have averages of 5. But which one would you say have a much wider range from their average? Yes, the second set. Good. So the second set have, even though they both have the same averages, the second set have values that are further away from the average than this set. Okay? Now, there are many ways to kind of indicate, to show the difference of that. Standard deviation is one of them. Okay? So standard deviation will show how wide the range of values from the average. Okay? Are we good so far? So in this case, the short form for standard deviation is usually STD-DEV. Okay? On Excel will be STDEV. Okay? So in this case now, I do not expect you to be able to calculate standard deviation by hand. Okay? We're in the bio class. I'm not teaching you math, so to speak. I'm teaching you how to use the math. You will calculate it on a spreadsheet, which will do the job for you. Okay? So in this case, standard deviation of these two sets, because this is a wider value than this one, like all these numbers are much further wider range from here. So the standard deviation of this will be a bigger number. This one will be a smaller number. Are you guys good? So standard deviation indicates it shows to other people that how wide are your values within your sample from your averages. It's one of the calculation a lot of biology teachers use. Okay, so that's why I want to show you guys that. Yes. So let's just say, and I will strongly recommend you guys using Excel. Okay, If you don't have Excel on your computer, you can access it onto, what is it? Microsoft Office. Log in. You guys can log in there with your TDSB account. Okay. So right now, as you can see, I'm on I logged in with my TDSB account. You guys can do the same thing too. So you will just use Excel. Okay. Now I'm just going to use this one that is on my computer. It's a little bit faster. So let's just say I'm going to use this set of numbers. Okay. So set 1, I have. So set 1, I have 5, 5, 6, 4, and 5. And this one here, 5, 10, 0, 8, and 2. Okay. One nice thing about Excel is this. Do they teach you guys, is there like a course teaching you guys how to use like a spreadsheet? How do you use various kind of programs? What? Grade 9 introductory to business?
Yeah.
But not everyone takes that one though, am I correct? You learn accounting. Well, again, if you're in business, okay. So in grade 9, when I was in high school, there was a course, grade 10 computer science. It's not really computer science. It was really teaching you how to use Microsoft Office, all 4 things of Microsoft Office. But this is a really good course, very useful course. So anyways, one nice thing about Excel is this. So look up here. Look up here. So let's just say I want to calculate the average of this one here. So I will type in equal, and I just type in average, bracket. And I can either enter this one, comma, this one, comma, this one, comma, and do it that way. I could do it this way. Or I can just drag, click and drag and show, like, oh, I want to calculate the average of these 5 numbers. Close the bracket, press enter, it calculates for me. You guys good? Now, not only that, let's just say down this row, I also want to calculate the average of this row. What I can do, look up here, there's, maybe I should zoom in a little bit more. You see here, there's a little dot at the end of this selected cell. You click on this dot, you drag it down, it would calculate the average for you. Okay, basically they just repeat the same calculation that you did up here, but with the numbers down here. Okay. Now standard deviation. Standard deviation. Okay, so in this case, you're going to calculate standard deviation. Now, let's just say you don't remember all these kind of equal and then the shorthand of it. What you can always do is go insert, okay, maybe not with the equal sign, insert function, and you can pick, now you can scroll down to see if they have standard deviation. Oh, there's standard deviation, STD. Okay, so estimate the standard deviation based on a sample. Okay, you are basically finding how different the values are within the sample, so you use this one, stdev.s. You click on that. Yeah, maybe zoom out a little bit. Click on that, and again, I would select these 5 numbers. Okay, click, gives me this number. Standard deviation of this set is 0.7 something. Now I can click on here and then drag it down, but I just want to show you one more time so you can remember how to do it. So I would insert function, standard deviation dot s for the one for sample, and press OK, drag across here. Okay, you guys see how big the numbers difference are? Okay, so that's how you would calculate standard deviation using Excel. Okay, right now I'm actually using your version that you can access on online. Now, different version have slightly different interface. However, this is also one of those things where that's why down here I have different videos you can look up, and there are tons of YouTube videos on like how to do this thing on Excel. Okay, you can always look those things up. Okay, any questions so far? So in this case, you will need to show the standard deviation of your data using Excel or Google. So your process data. Now your process data table need to be very simple. Essentially, your independent variable, okay? Your dependent variable. Now, remember, your dependent variable is either percentage or rate, okay? If you don't understand how to calculate rate, come and talk to me later on. There are many ways calculating rate depending on your results. Okay, different people may have to do it slightly differently. And average. Okay, so this one should be average. Sorry. So this column here should be average of your standard deviation, no, dependent variable. And this column here should be your standard deviation. You guys good? So your process data table is extremely simple. Your independent variable, your average of your standard dependent variable, and then your standard deviation. Good? This is to be done on Excel. After that, you're going to be creating a graph. Okay? You're going to create a graph. Now, a couple of things about graphs. Should be large and easy to read, have a proper and descriptive title. Okay? It should be very similar to your aim. You need to have labeled your axes, show the unit as well as uncertainty. Make sure you plot the averages. Okay? I lost count a number of times. People just plot like, this is my line for all my trial ones. This is my line for all my trial twos. Don't do that. Calculate the average and then plot the averages. Use a scatter point plot and then add a trend line and equation. I also want you guys to include R2 value. Okay. Also include something called R2 value. It is not a difficult thing to add, especially on Google Sheet. They would actually teach you how to do that. Okay. R2 value is an indication of how, when you do a line of best fit, how close are your data from your line of best fit. Okay. Questions so far? Yes.
For the graph section, do you want us to like make a separate graph for like each day of the process? Or?
That's a very good question. I'm just going to repeat it. Do you need a graph for each day? No. I would expect one graph that will best represent your data. So this is a part where like it really depends on your result. Let's just say in day one, only a few of each set got germinated. In day two, you actually start to see a pattern. Okay, let's just say two view to see pattern. Okay, pattern can be seen in let's just say by day 3. Oh crap, everything germinated. So because everything germinated, it's really hard to see pattern. Okay, everything germinated. Can't see pattern. Okay. So in this case, which day do you think I would use? Day 2. Because I can actually see a pattern. Okay. So I'll probably be using day 2. Again, it really depends on your group's results. Some group, you might actually slowly see a pattern. You can go up to day 3, then you use day 3. Are you guys good? Okay. So there should only be one graph. Here are some example of graph. You guys do not need to do these thing called error bars. I think that's a little bit too much for grade 11 for you guys to do. Just stick with just the line graph. Okay. Also, another thing too, you might not have a linear line graph. Your data could be a curve. In biology, we deal with a lot of curve line of best fits. So just keep that in mind. Okay. Questions? Okay. So in this case here, that's your group part. Okay, that's your group part. You need to hand that in, and you should hand that in as a group. Now your individual mark. What do you need to do? First off, you describe the trend of your graph and refer to it in detail. What I mean is this. Let's just say, I'm just making something up right now, okay? So let's just say, okay, so this is, yes. Okay. So in this case, let's just say this is concentration of something, and this is percentage germination. Okay. So in this case, let's just say that's my line of best fit. Those are my values in my line of best fit. So what I will say when I say here, describe the trend of your graph, what you will say is this. Using this as an example, so you can say when the value is below, let's just say this is 2. I'm making up a number. When the concentration is less than 2, there is the percentage germination increases quite sharply. Okay, so you can say increases quite sharply. After concentration of 2, whatever it is, you'll know that the percentage germination is increased would be slower, and up to a certain point here, let's just say by 4, after concentration of 4, whatever it is, it barely increases. Does it make sense? So this is the part where you're referring to the trend, the shape of the line, using the points in detail. Are you guys good? This is all recorded, by the way. Number 2, give scientific explanation of the trend. So what this means is, well, now you need to explain why is it that when the concentration is from 0 to 2, it goes up really fast, but then in between 2 to 4, it's slowed down, and number 4 or 5 afterwards, it's barely make any difference. So you can say, oh, maybe because when you go from 0 to 2, blah 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 blah, you try to give scientific explanation to why. You explain your result. Now here, I do want you to say, okay, so in that case, does that fit your original prediction? Okay, did this fit your original prediction? Let's just say yes. Okay, if it fit your original prediction, say yes. If it didn't fit your prediction, say no. You say, no, it didn't fit my original prediction because we were expecting something like this. And it turned out not to be the case. Okay? Now, this part here, it's important because in science, your result could be whatever it is, but it might be different from the textbook or other experimental results. So this is the part where you compare your data with published sources. So for example, here, let's just say you found, best case scenario, you found another experiment online that is doing exactly the same kind of thing. When I'm talking about experiment online, I'm not talking about some other student's lab report that they upload onto, I don't know, Course Hero or some other random websites. Okay? Not those. I'm talking about, oh, certain university was doing this experiment and they found blah, blah, blah. Okay? Not some other student's lab report. So in this case, you compare. Like if you say, oh yeah, our result is very consistent with Johnson & Johnson's result from University of Montreal or something. Or you might say, you know what? Our result is nowhere close to what published results are doing. Our result is like this, published results like this. You say that. You're not going to lose mark on your results. But if you don't explain things well, you will lose mark that way. Okay? So if let's just say published results say this, then you say, yeah, our result is quite different from the published result. Published result actually talk about this way. Okay? Any questions so far? In grade 11, I'm not going to ask you to explain why you think your result is like this and published result is like that. I'm not going to ask you to do that, especially for this lab. But I just want you to be able to explain your graph and compare with other things. Are you guys good? Make sure you cite the published resources. So in-text citation using APA. Also, have at the very end, 2 to 3 line paragraph as a final conclusion. So go back to answer your RQ, okay, referring to your data. Okay. Any questions? This is taking a lot longer than I thought. So that's your individual mark portion. Okay, I'm gonna create 2 different drop boxes, one for the group stuff, one for the individual stuff. However, I will need hard copy. Okay, the hard copy can be, the group portion can be just 1 copy of the group. Okay, but then individually you have your the individual portion. By the way, this is half a page to 1 page single space. Okay, half a page to 1 page single space. Any questions? Now, the rubric is here. So you can click on it and see the rubric that I used for last year, and I'll use the same rubric. One thing that you're lucky that you don't get to, that last year's students didn't get to have, I have here a list of general feedback. So typically when I'm marking labs, I will have a document saying, oh, these are the general feedback that would probably apply to most people. You guys can access the general feedback that I gave to the class last year and learn from their mistake. You guys good?
So we
What? In that sense, yes. Okay. So again, everything is due on not this Wednesday, but next Wednesday, the 12th. Okay, in the beginning of the lesson. Are we good?